Okay, we live. Should be good to go. Okay, so for this session, let's get up. Okay, so for this particular session, I'm going to be looking at how well the models or how well the synthetic datasets that I've been creating can actually generalize for different types of model fits. We've already seen that for the actual models of interest, that our synthetic datasets seem to perform quite well. But one of the things that you want to show with these synthetic datasets is that people can actually do exploratory analysis on the data, and because the data the variables have the same sort of relationships with each other within the synthetic data sets, or you'd hope that have the same sort of relationships with the original data, that when people are constructing novel models that you haven't looked at before, they actually closely reflect what you would find in the original data set. So you want to demonstrate two types of utility when it comes to synthetic data. The first is specific utility in that your models, or the ones you're proposing, are actually the same, and that's quite easy to test. But the second one is looking at general utility, which is what I just described, that people can fit new models and they're still going to make sense with the data. So the way that we're going to do this, I've been guided quite a lot by this excellent paper by the authors of the synthpop package, which is guidelines for producing useful synthetic data. And if I'm going to be doing a paper on this, I should probably know these guidelines. So let's have a look through. Just making sure, getting some sound through. We have shown before that we do have this utility for the models, but what we're looking for now is this general utility. And the first thing is these graphical methods. So one thing that we have done previously is we've looked at the overall distributions. So let's run that again using this function. That should be the one. Okay. Let's find out. It's making a plot. Just checking that the stream is working a-okay. Should be okay, but always good to check. Okay, so we can see that, yeah, we're good. Yeah, so we can see, looking at these plots here, that looking at the general distributions or the general frequencies of the variables, these are looking quite similar between the observed and the synthetic data sets. I'm fairly happy with this, and we've seen this before. But what we want to look at is the relationships between these variables. We want to make sure that the distributions between these variables, or the patterns, are actually quite similar. And as is suggested in the documentation here, you can use this multi-compare function, which I just discovered from reading this paper, and it seems really cool. Let's have a look. So you can do, we'll run this last one. You can adjust the bin width. That might come in handy. When you split, this is looking at the measure of religious affiliation. You would expect religious affiliation to be equally, or the levels of self-reported religious affiliation to be equally distributed between the oxytocin and placebo conditions, because these conditions were randomized. So there's no reason to believe these would be different. But regardless, this will be interesting to see that for the raw counts, when it comes to the observed red and the synthesized blue, the raw counts of religious affiliation seems to be quite similar. But then what we can do, I think, let's look at this other one here. You can do box plots or histograms. The box plots looked a bit weird, but let's just run this again. The medians for the box plots from memory looked a little strange. So this is the same sort of data. This is looking at ratings of self-reported spirituality. There should be differences between oxytocin and placebo because that was the main outcome. The synthesized data looks extremely similar from the observed data. Let's run that as a histogram. It's not entirely clear. And let's get up the help. Okay, we'll run this first and see. What does it give us? What does it give us? Here we go. Cool. So this is looking at self-reported spirituality between the oxytocin and placebo groups. There's a bit more of an increase in the oxytocin group, which is what's reflected there. Now, what's interesting is that when we do the model comparisons, the synthesized model doesn't actually find a significant result. Oh, this is very interesting. Okay, let's go back. To the main ANCOVA. I believe that's the one. So this is, speaking of direct specific utility, this is looking at the specific utility of the model. So the main outcome that we want to demonstrate with our synthetic data is that there is an effect of oxytocin nasal spray on self-reported spirituality once you account for religious affiliation. So this is the coefficient here. For the observed data, as was reported in the paper, there was a significant effect. But for the synthetic data, although the patterns are very similar, and if we are to look at, there's over 88% overlap between these confidence intervals. This one is insignificant, and the reason this one is insignificant is that for some reason, the data synthesis, this is really cool. For some reason, the data synthesis seemed to underplay the frequencies or the counts. So for the observed, we had over 11, about 12 that scored around 5, and 5 that scored around 6. That seems to have made up for it though. Okay, so there seems to be differences here which seem to have affected the outcome. But that happens. But what's more important is that the effect and the confidence interval, what's more important is that the effect is extremely similar, regardless of statistical significance. One thing I think you can do, if we look at this documentation here, is we can do multiple plots. Yeah, we can. And adjust the bin width. Let's try that. So we can see, because when you look at the recommendations here, it says, if resources allow, this should also be used for all pairs of variables that may be used in inferences. So I like that. Highlighting. I'll highlight that. So that means we can do make our code a bit clearer. OT condition. Maybe not. Check it again. Let's just see. It looks like that needs to be continuous or categorical. Variables. Let's just see what happens. Let's just see what happens. It's working. It's thinking. That doesn't look clean, but yeah, that's not very informative. What if we do box plot? How do they spell it? Cont type. Box plot, one word. Yep. Box plot. Box plot. What is this going to give us? That is also not very informative. Okay. Go back to the documentation. So it only seems to work when the by is categorical or some sort of continuous, not continuous. Some sort of, yeah, categorical variables. Let's adjust bin width. Let's remove that because that hasn't been very helpful for us. Double check that still. Remove that. Bin width. What do they use? 5. That's not going to work. Hist. Ooh. 2. 1. See how that goes. Oh yeah. But it's not very clear because there's no gap between them. I don't know if I like that. Let's try it without. Bins equals 30. Really? That still seems to be better. Back to the documentation. Let's try bar plot again and try this dodge thing. Bar plot. Bar plot position. Dodge. Object P not found. It's already not very informative. Alright, forget that. Still think the hist seems to work the best. So that is the main outcome we're interested in. We also want to make sure that there wasn't any sort of weird effects of religious affiliation between oxytocin and placebo. So let's run the same thing. And then we can report. Religious affiliation. Where'd you go? Yep. There. And we can report these things too. These two things look similar. And then what does this do? What sort of plot does it give us? Okay, so the age distribution for every level of religious affiliation. What if I was to flip that? No, that would be way worse. No, it's just the sample sizes aren't great. And when you have these 7 plots, including NAs, the counts are nothing. Yeah. Well, what we can do is collapse them together. No. What if we were to look at the scatter plots between these two, put them on the same plot. Oh, I wonder if you can do that. Let's find out. We're going to search, go to the documentation. That is not what we want. Go to the documentation and then search for Scatterplot. I think I've seen this somewhere before. This will be cool. So then we can look at some sort of... Let's go to this. This book is so good. You need to check it out. It's free online, or you can buy the print book. Visualizing relationships. Associations among two. Scatterplots. That's exactly what we want, but let's see if we can... Paired data. Oh. Yeah, is that what we want? Maybe. Slope graph. So then we are looking... No. Then we can do this sort of graph and we can see, is there a bias? First, can we extract... It's going to be tricky stuff, but it should be doable. We just did this one, that by that. Let's put it into an object. What does that give us? No. This is the... No, that's the main data set. Is it a data frame? It is not a data frame. Let's make it a data frame. Is that going to work? Probably not. Nope. Okay. Got it. Back to help. The variables and values should be factors or variables with a few values. Yeah, just as I thought. Well, for now, what we can do is we can start writing this up. I don't know if I'm going to use propensity scores. Required when making compare. Univariate distributions. Function in construct, yeah. Univariate distributions. Another word for visualize. Nah. Univariate distributions. Side by side. Of synthetic observed datasets. Back to the recommendations. This can be used to confirm gross deviation. It has also been recommended. It is also recommended? Yeah, it is also between also recommended to visualize Z, S, as long as it's consistent, of interest. Good. Good, good. Ha! Thanks, got a comment. There we go. So I got a great comment from Scooch. It's great to see you're not abusing your thesaurus. It's crazy how many academics overuse complex words. Look, that's such a great point. And I rely on my thesaurus so much when I'm writing, just to see that there's I'm not using original words, but that there's no point in making things more complex than have to be. So Scooches, thank you for the comment. Okay, back to writing. He's also recommended to visualize between specific variables' interest. Let's go to the example here. All right, so we have our example. How did I write it previously? Copy and paste. You can't plagiarize yourself in your own paper. Or can you? No, you can't. Might make yourself a bit too repetitive. There. Bivariate comparisons between specific variables of interest were also visualized. Fig X. This looks like this. I do think it would be really interesting to do a plot like this to demonstrate whether there's any specific biases. No. Maybe just a simpler plot. Like that. Or some sort of... That could work. Bivariate comparisons were also visualized. Check that again. Well, I think that's the main one, a bivariate comparison of self cannot spell today. Nasal spray groups. Suggested that the counts between synthesized and original datasets. Similar. So if I want to give this Scatterplot thing a crack, Scatterplot thing a crack, I need to extract the raw data and do those comparisons there. But for now, I think I'll leave that for another time. What else is recommended here? Yeah, that could be nice, but that seems to work when you have larger data sets to make a plot like that. Yeah, and the utility from fitted models we have already demonstrated quite nicely. Okay, I am going to wrap up for this little session. Made a little bit of progress, but that's what writing a paper is all about. Just plugging away and hopefully improving bit by bit. Thanks for watching, and I'll be back again probably on Monday with my next live stream. See you later.